Hello everyone, myself Ketan Bausar. Hello everyone, myself Ketan Bausar, Assistant Professor in LJ Engineering College, Ahmedabad, in Image Processing subject, Unit number 4, Image Restoration and Reconstruction. And today's topic about noise reduction, and in the depth of noise reduction that we study the different types of filters. In previous session we discussed about different types of noise model and the reduction techniques. And in reduction technique we discuss about the different types of filter, like mean filter is there, Mendel filter is there, arithmetic filter is there. And also we study the different types of filter, that how we choose a specific type of filter to remove the certain types of noises, and how we remove this type of the noises and we get actual result or not. So it play a main role when we choose a specific type of filters. Now in today's topic we discuss about a degradation model or about mmse filter. Now, the first question arises in our mind is that what is the degradation model? That I already told you in previous session that degradation play a main role when you choose any type of the filters. See, if you're talking about the different types of noise model, then we definitely have to choose a different types of noise models. We add the different types of noises. It can be artificial or it can be natural noises. And because of this type of the noises you are getting the result, it's a g of x comma y, means it's your degraded content. And to extract your original content, which is approximately f of x comma y, which is your original image, for that you have to use a restoration filters and the restoration content. And for that restoration content you have to choose a specific type of filters. And which filter that we have to choose, it totally depends on the noises that add in your image. So for choosing a specific filter, that we have to work on specific type of images and specific type of noises. And in previous session we also discussed about the different types of filter generally used to remove the certain type of noises, like which is harmonic noise, Gaussian noise, salt and pepper noise, uniform noise, relight noise. So we can remove the different types of noises using the certain type of filters. Now, noise reduction technique. So if the certain type of noise generally added in your image and you want to extract your original content, then definitely you have to add or you have to use a certain types of filters. And for that particular type of filter you have to use a masking approach and the neighborhood based concept in filtering concept. So as you can see in this image, it is your distorted image, and after applying the filter your images look like this. So practically it is very difficult to achieve this type of the image, but with help of choosing a specific filter we definitely try to achieve this type of figures or this type of image. Now, as you already know how the different types of noises are added in image, as you can see, atmospheric, optical, sensor based, motion blur, noisy, there are the different types over there. Now we use different types of filtering. Now what is inverse filtering? The image restoration, the goal is to recover the image that has been corrupted or degraded. Or corrupted means it can be because of the noise or because of some time constraint. It can be degraded or corrupted. The more information we have of the degradation process, the better off we are. This is known as a prior knowledge. There are several techniques in image restoration. Some use frequency domain concept and other attempt to model the degradation and apply the inverse process here. The modeling approach requires determination or criteria of goodness that will yield an optimal solution. The blur image, that is the result of conventioning a Gaussian filter into the width direction with the original image. So with help of the Gaussian filters, we try to achieve the original content. This effect is similar to the one observed when a photographer is taken with a camera in motion. So how we can justify different types of noises, or how we can justify the Gaussian noise that we remove from this image. So for that we have add some Gaussian noise when the camera object is moving and camera is shaking during capturing the image. So we can understand the concept with this type of figures. Let F be the original image, H the blurring kernel, and G the blurred image. So the idea is inverse filtering is recover the original image from the blurred content that I already told you. So with help of this type of the content or this type of the method, we can extract a meaningful content from a blurred or distorted content or corrupted content, we can say that. And in previous or in current situation, there are the different types of softwares is also available to extract the meaningful content from the distorted content, but for that it requires specific skill, or also it requires specific types of methods. The conventional theorem, the DFT of the blur image is the product of the DFT of the original image and the DFT of the blurring kernels. Thus, dividing the DFT of the blurred image by the DFT of the kernel, it's basically a Fourier transform based concept that how you can take original content from the degraded content and how you can receive a meaningful information, and make sure that whenever you try to extract your content, you have to capture your images and you have to make sure that your return content or your extract content should be optimum, means it cannot tolerate with your original information. We are assuming no noise is present in the system. So observe the difficulty we incur when h of u is very small and is equal to 0. Definitely if there is no noise, means it is in ideal condition. Now we can optimize this equation with help of the mathematical term like g of x is equal to f of x into h of x, and optimize by g of u is equal to f of u into h of u. So by adding the Gaussian content, f of u is equal to 1 up divided by h of u into g of u. So f of u, we can say that it's r of u into g of u, means r of u is equal to 1 divided by h of u. So the formula correspond the one-dimensional case and can be easily extracted to the 2D domain or two-dimensional content. Now we identify these terms with help of a mathematical model or in terms of the two-dimensional data. Then we have to take care of two-dimensional information in terms of rows and columns. So P of u comma v is equal to h of u comma v into q of u comma v. So it is a degradation image, degradation transfer function, and original image. So we can extract the original content with help of the degraded content divided by the degradation transform function. Means we have to apply the inverse transform to extract a meaningful content or to extract the meaningful data from the image. So it play a main role whenever we try to extract the original content from the image. So as you can see, the spectrum of the one-dimensional data, it's look like this, and if you apply the inverse transform, then your image again convert in this particular format. Because whenever you discuss with this type of the filters and whenever you discuss with different types of noise models, in each and every scenario we have to make sure that your transform function and your inverse transform function order, functionality, parameters, it should be in equal manner. If it is in equal manner, then definitely you can extract a meaningful content from the image. Now we move on the next topic. It's a weiner filter, and it is also a very popular filter as compared to the adaptive, mean, median, arithmetic, Gaussian filters. Now what exactly the weiner filter is? The weiner filter is a mmse optimal stationary linear filter for image degraded by adaptive noise and blurring. And calculating of the weiner filter require the assumptions that the signals and noise process are second order stationary. I mean, it is a random process that it try to reduce the mmse value and use a linear filtering based concept to acquire the meaningful content from the image. So usually the weiner filter are usually applied in the frequency domain based concept for getting the better optimization of the result or getting the better outcome from the images. And given a degraded image x of n comma m, and after applying the DFT we are getting x of u comma p. So means with help of the transformation based concept we extract the meaningful content. So to origin the image spectrum is established by taking the product of x of u comma v. With the weiner filter g of u comma v can be extracted. So as you can see, h of u comma v, it's a Fourier transform at the point spread function. P of s u comma v, it's a power spectrum of the signal obtained by taking the Fourier transformation. And also auto correlation function p and u comma v. So with help of different types of noises or because of the degradation model, we try to extract the meaningful content, and it play a main role when we discuss about the different types of filter domain. As you can see, these are the mathematical terms that you have to make sure that these terms are you have to remember in your exam, because see, each and every terms have some mathematical calculation. And so see here the weiner filter equation is g of u comma v is equal to h star u v p of s u v h u comma v square p of s u comma v plus p of n u comma v. So basically these are the standard equations that you have to follow whenever we work on the weiner filter in terms of the rows, columns, degradation function, actual images, and etc. And also we try to extract the meaningful content with help of the dividing the p of n u comma v divided by p of s u comma v, and we getting the variance in terms of the row n square. So you can see the image variance. So with help of the mean value and the noise variance we can extract any type of meaningful content from the images. So weiner filter are able to reconstruct the frequency component which have been degraded by the noises or can be degraded by the noise model, and they can only suppress them. Also the weiner filter are unable to restore the component from which h of u comma v is equal to 0. So means if you are in ideal conditions, then definitely there is no noise is available, so you can definitely extract the meaningful content from the images. So I hope you are getting the idea about different types of filters, and you have to get idea about what exactly the weiner filter is and how weiner filter is better as compared to the different types of filter. Because if you have a noise like the blurring, moving content, distorted content, corrupted content, then definitely weiner filter is provide the better outcome as compared to the existing figures or existing images. And also make sure that in this particular chapter we have to study the different types of noise model, which starting from the uniform noise, salt and pepper noise, exponential noise, relight noise. So there are the different types of model, and also we study the different types of noise filters, like it is a mean filter, median filter, also adaptive filter, and after that move ahead we go with a inverse filtering and mmse filter. So if you have any doubt, then you can contact me. So I hope you are getting the idea. So thank you very much.